This is RD Sharma solution class 12 chapter 17. We are taking increasing and decreasing functions. The exercise is 17.2. Show that the function fx is equal to sine 2x plus pi by 4 is decreasing on 3 pi by 8 and 5 pi by 8. This is the interval being given. So what are we going to do? First thing is to differentiate. Increasing, decreasing means differentiation. The first thing has to be differentiate. So sine theta differentiation is cos theta. That is cos 2x plus pi by 4. Then we have to differentiate 2x plus pi by 4. So it will be 2. Now this one, this f dash x should be less than 0. In order for this to be decreasing, it has to be less than 0. And the x is in between 3 pi by 8 and 5 pi by 8. So let us write this. X is between 3 pi by 8 and 5 pi by 8. Now try making it 2x plus pi by 4. For that we have to multiply both sides by 2. I'm multiplying both sides by 2. What do you get? This 2 4s are 8. So 2 4s are 8. You get 3 pi by 4 on the left and 5 pi by 4 on the right. So now 2x is in between 3 pi by 4 and 5 pi by 4. Next is to add pi by 4 because we need this angle, so that we can go ahead and define the decrement. So I'm now adding pi by 4 on both the sides. Since the base is same, so just add the numerators. 3 pi plus pi is 4 pi. We have 4 pi by 4. Pi gets cancelled. So you have a pi only. 2x plus pi by 4. Now 5 plus pi is 6 pi. 6 pi by 4 is 3 pi by 2. So this becomes 6 pi by 4. You can just cancel this with 2. 3 pi by 2. Pi is in between 3 pi by 2. Now you don't have to worry about anything because if you are aware of trigonometry and you can explain through trigonometry that the angle between pi and 3 pi by 2. So when we say add sugar to coffee, this pi and 3 pi by 2 means 180 degree and 270 degree. So we have the angle between pi and 3 pi by 2 which is 180 degree and 270 degree. So now tan is positive here. Other things, other angles, they are negative. So cos 2x plus pi by 4 between pi and 3 pi by 2, as I suggested here, and this is the established fact, that is less than 0. Multiply both sides by 2. It doesn't matter on right because multiplication with 0 will give you 0 only. So whole expression that we found is less than 0. And that we wanted to prove. F dash x is, if it is less than 0, then the function is decreasing. So this is decreasing in this interval. Okay. Now I got to show you the information which you have to write when this question comes, or the content. So all these you have to write for all x and c. I give always the logic. The written material is what you have to complete. So show that the function. The question of this sort of tan inverse we have already taken, if you remember. Now this is decreasing on 0 to pi by 4 and increasing in pi by 4 to pi by 2. So there is a slight change in this question because we are talking about pi by 4 is this one. Pi by 4 is simply 45 degree. So 0 to pi by 4 is this one, and pi by 4 to pi by 2 is the above one. That is pi by 4 to pi by 2 is the other half of the first quadrant. So add sugar to coffee we are going to use. So we will differentiate it first. So cot inverse x differentiation is negative 1 by 1 plus x square. What does that mean? We have sin x plus cos x in place of x in this case. So when we take the differentiation, it will be just negative 1 by 1 plus sin x plus cos x whole square. So we have this sin x plus cos x whole square. We have sin x plus cos x differentiation as cos x minus sin x. So numerator denominator we have already differentiated now. Now I am opening the denominator. So sin plus cos whole square is sin square plus cos square plus 2 sin x cos x. Now this sin square cos square is 1. Means sin square theta plus cos square theta is equal to 1. And then we have this 1 plus 1. You can write 2 sin cos as sin 2x, or you can just keep it like 2 sin cos x also. Now this is negative in the numerator, so I'm just swapping cos and sin so that we can eliminate this negative sign. Now I'm writing whole sin x minus cos x divided by, this is 2 plus 2 sin x cos x. Now this one, either you can go for numerator and denominator separately, that you can show that whether it is increasing or decreasing. I'm taking this 2 outside. So this 2 I have taken outside in the denominator. So it has to be decreasing on 0 to pi by 4, that we have to show. So this has to be less than 0. F dash x should be less than 0. And it should be increasing in pi by 4 to pi by 2. There is a slight mistake in the question which is written here. I'll just change it just now. So first we'll show it decreasing in 0 to pi by 4. So I'm writing it short because it will take time. So sine and cos s and c. F dash x should be less than 0 in order to show that it is decreasing in 0 to pi by 4. That is the interval being given, the first interval. So both sides multiply by 2 1 plus sine cos. That is, if you multiply both sides by twice of 1 plus sine cos, this gets cancelled, and on the right also it will be multiplied by 0, so only sine minus cos should be less than 0, or sine should be less than cos. If you divide both sides by cos theta, it will be 10x less than 1. Now 10x less than 1 is between 0 and pi by 4. We already know tan 0 is 0 and tan pi by 4 is 1 by root 2. So it is less than 1. 0 to pi by 4, it is less than 1. You already know that 1 by root 2 is what. So sin x is less than cos x. We divided both sides by cos x. And in the previous question of this sort, exactly like this sort, I told you, find out the value of sine 0 and sine pi by 4. Find out the value of cos 0 and cos pi by 4. Show it on the number line and you'll see that actually this cos is higher than sine in this range 0 to pi by 4. So between 0 and pi by 4, if you just take angle also, so tan 0 is 0, tan pi by 4 is 1. So you're talking about anything which is less than 1. In number line also you can show that. But we already know that it is established fact between 0 and pi by 4, tan x is less than 1. How about f dash x greater than 0? So sine minus cos divided by twice 1 plus sine cos. This should be greater than 0. So greater than 0 means multiply both sides by 1 plus sine x. Twice 1 plus sine x will be better, which we did in the first part also. So when you multiply this, on the right it is multiplied by 0, so it will remain like that. And here it will all be cancelled, so sine minus cos x should be greater than 0. That is, sine x should be greater than cos x. Again, as I said, it is the interval is a slight mistake in the question. So it is pi by 4 to pi by 2. So when you divide both sides by cos, it should be tan x greater than 1. So x is between pi by 4 and pi by 2. It is already given in the interval. So when it is given in the interval, you know tan pi by 4 is what? It's tan pi by 4 is 1. And tan pi by 2 is infinite. So actually it is greater than 1. So I am saying this is not 0 to pi by 4. It is actually pi by 4 to pi by 2. So when you take x between pi by 4 and pi by 2 and you want to ask for the angle, tan by 4 pi by 4 is 1 and tan pi by 2 is infinite. So it is actually greater than 1. 1 to infinity is greater than 1 only. In the previous part we said tan x is less than 1. That is, it is 0 to 1 in this 0 to pi by 4. Here pi by 4 to pi by 2 is higher than 1. So f dash x is greater than 0. So it is greater than 0. It is increasing in this interval. So how are we going to solve this? This is the whole procedure. You just add here, because I told you there is a slight mistake in the question which is being printed here. It is increasing in between pi by 4 and pi by 2. Alright, just write it decreasing and change the interval and write it here. I'm writing it here. I'm just changing what I initially intended. I told you that there is a slight change here, pi by 4 to pi by 2. Show that fx is equal to x minus 1 e raised x plus 1 is an increasing function for all x greater than 0. Just find out f dash x. When you take f dash x, we'll follow the product rule. Differentiation of 1 is going to be 0. So just eliminate that. We have x minus 1 e raised x. So x minus 1 e raised x, then e raised x. X minus 1 differentiation will be 1 only. So when you take e raised x common, it will be x minus 1 plus 1. So 1 gets cancelled. You will get x e raised x. So the whole idea is to show that x into e raised x should be increasing or should be greater than 0 when x is greater than 0. When x is greater than 0, x will be positive. When e raised x is positive, again e raised x is positive, that is e is a constant number which is 2.714, like that. And if you take any positive number over it, means as the power, it's going to give you positive only. So x raised ex should always be greater than 0. So f dash x is greater than 0. So this function is increasing for all x which is greater than 0. So the things you have to write here is like this, and this for all and all these mathematical symbols you need to use so that you complete the answer and explain it to the examiner. Show that the function x square minus x plus 1 is neither increasing nor decreasing in 0 to 1. Now just concentrate on 0 to 1. So if we are able to show between 0 to 1, it is increasing somewhere, it is decreasing, we are able to show neither increasing or not decreasing. So first is f dash x, it is 2x minus 1. So if it is increasing, it should be for f dash x greater than 0 and less than 0 if it is decreasing. So 2x minus 1 is greater than 0, 2x minus 1 should be less than 0. 2x minus 1 greater than 0 means 2x should be greater than 1. Here 2x should be less than 1. Here x should be greater than half. Here x should be less than half. Greater than half means, so just in between 0 and 1, what you are going to get? So it is increasing if it is higher than half. And you just have to concentrate between 0 and 1. So half to 1 it is positive, it is increasing. X less than half means you are talking about this part where it is decreasing. So in between 0 and 1, one time it is decreasing, one time it is increasing. That means it is neither increasing nor decreasing. That is the conclusion we can draw. So here you see, I'll just show you the way you need to go about and write all those stuff which I explained. And case 1, case 2 will be better, and showing with on the number line, the diagram is always beneficial for you to make the examiner understand that you know everything and you have solved it with all your intellect might. Show that the function, this one, is an increasing function for all x belongs to R. Now first one is differentiation. I already told you increasing, decreasing means you have to differentiate. X raised 9 is 9x 8 plus 7 4 is 28. 28x 6, x raised 6, and this is going to be 0. Now the only thing which you need to understand or to explain to your examiner, that anything with power 2 or anything with the power even, whether it is negative, whether it is positive, it will always be positive. So the square will make negative to positive. Positive is already positive. So even if it is negative and the power is even, it will be positive always. Okay. So x raised 6 and x raised 8, they are also greater than or equal to 0. Or you can write it as x squared to the power 4, 28 x squared to the power 3. It doesn't matter it is power 4 or 3. It is already squared. Squared will always give you positive value. So whatever you do, any number you place from real number, it is always be greater than 0. So what I told you, this is what you have to follow. There are just few lines you have to write. The whole idea is that even power of x will always be positive because it will make all the negatives positive, greater than 0. Next one is also like that. Prove that the function, this one, is increasing on R. So f dash x will be equal to 3x squared minus 12x plus 12, and 18 will be 0. So when we take f dash x, it is going to be, I'm taking 3 as common, x squared minus 4x plus 4. Now you already know x squared minus 4x plus 4 is x minus 2 whole square. You already know that from algebra. A square minus b square a square plus b square minus 2ab, that is the expansion of a minus b whole square. So it is always 3 is a constant. It is already positive. X minus 2 whole square, as I told you, anything with the power 2 or even power will always be positive. So when you multiply positive with positive, it is going to be positive only. So when it is positive, that means f dash x is greater than 0, or it can even be equal to 0, but it is increasing. Now how you are going to write about it? 3 greater than 0, it is a constant. X minus 2 whole square greater than or equal to 0. So fx is increasing on R. So this is increasing. So in real number, this function indeed is increasing. State when function fx is set to be increasing on interval a, b. Test whether this function is increasing on the interval 4, 6. So the definition is simple. Fx is set to be increasing in the interval a and b if f dash x. The differentiation has to be taken. Without differentiation, you won't be able to tell it is increasing or decreasing. So the f dash x in this a-b interval, it has to be greater than 0. In this whole interval, it's not that it is increasing somewhere, it is decreasing somewhere between a and b. It has to be increasing always between a and b. So we'll just try and explain this definition with this question, the second part. So we have to test. X squared minus cx plus 3, 6x plus 3 in 4 to 6. So I'm differentiating it. It's 2x minus 6. Now 2x minus 6, if it has to be greater than 0, I'm finding f4, f dash 4 and f dash 6. So there are two things which simultaneously I'm doing. F dash 4 is 2 into 4 minus 6. F dash 6 is 2 into 6 minus 6. That is 8 minus 6, 2. 12 minus 6 is 6. So what do you get? You get the value 2 and 6. Here also 2 is greater than 0, 6 is greater than 0. And there is no point in between where you get f dash x less than 0. Even if you put anything 5, 4.5 or say 5.5, you will always be getting increment. So let us see the reference solution here. And this solution has to be, see, the first part is the explanation of the definition, and second is the implementation of that definition. So this is f dash x greater than 0 is the whole idea, the key idea of this question. Show that fx is equal to sin x minus cos x is an increasing function in negative pi by 4 and pi by 4. Need to understand the negative part of anything is the mirror image in the trigonometry. So that is we are going to take in the next discussion just now. But first let us differentiate this cos x plus sin x. When you differentiate this, that is f dash x, we have cos x plus sin x, because sin x is cos x is minus sin x. When you see minus pi by 4 and pi by 4, if cos x plus sin x is increasing in this interval, It is increasing function. So f dash x is greater than 0, that we have to show. X is between negative pi by 4 and pi by 4, that is already given in the question. Now add sugar to coffee, just see here, add sugar to coffee. Now where pi by 4 is what? It's 45 degree. Minus pi by 4 is what? It's minus 45 degree. So I'm just taking cos x common here. It will be 1 plus tan x. So either you show that cos x is positive here and sin x is positive here. If you can show that, so that won't be possible because sin x in the third quadrant is negative actually. So you have to take those things which is positive in this range. If you take cos on both the sides here, cos minus theta is plus cos theta. Sin minus theta, tan minus theta is minus tan theta or minus sin theta. But cos negative theta is plus cos theta. So what do you get? This is 1 by root 2, 1 by root 2. But you know that you cannot go forward with this. What does it mean? X is between 1 by root 2 and 1 by root 2. That doesn't solve anything. So that is the wrong approach. But here, if you see, this is pi by 4 and this is negative pi by 4. So you are talking about anything which is in between this area. So all is positive, cos is positive. Between minus pi by 4 and 0, it is going to be positive. So basically minus pi by 4 and pi by 4, cos is going to be positive. So we change this into cos x into 1 plus tan x. So we already have shown that cos x is greater than 0 in this, through the diagram and through the trigonometry. Now come to the second part, which is 1 plus tan x. If we can show this 1 plus tan x as positive, cos x already is positive. Multiplication of positive will be positive. So it will be an increasing function. So we'll go with 1 plus tan x and try to show that it is in between negative pi by 4 and pi by 4. It is actually positive. So tan x is what? Now minus pi by 4 and you have x, it is pi by 4. Again, same thing I'm taking. There is no other logic, you know. The things are given, you just have to go forward with all your background knowledge. So let us take the tan of all these. So if I take tan, it will be tan x in between. It will be tan negative pi by 4. This will be tan pi by 4. Now tan negative pi by 4, this was not logical. X between 1 by root 2 and 1 by root 2, what does it actually mean? It doesn't mean anything. But when you take tan minus theta is minus tan theta. And tan pi by 4 is what? It's 1. So tan x is between negative 1 and 1. I'm saying when we took tan pi by 4, tan minus theta is minus tan theta. So on the left of tan you got negative 1. On the right of tan you got 1. Tan x between negative 1 and 1. Alright. So just add 1 to all of these. When you add all of these, you'll get 0 here. This 1 plus tan x and less than 2. So what do you see? 1 plus tan x is actually between 0 and 2. And between 0 and 2, that means it is positive. 1 plus tan x starts from 0 and ends with 2 in the interval minus pi by 4 and pi by 4. So this is positive. We already showed cos is positive. 1 plus tan x also is positive. So when we multiply positive, it is going to be positive. So it is greater than 0. So positive multiplication is positive, it is greater than 0. That is f dash x is greater than 0. So it is greater than 0 and it is positive. That is what we wanted. And then we showed that actually this is sin x minus cos x is increasing in this interval. Now I got to show you how you are going to go about it, because writing is more important. Whatever you know, you have to put it on the paper. Otherwise, there is no way the examiner would understand that you know all of it. So this question has a slight variation here. People have solved with cortex also, but the logic remains the same. Just go forward with what I have explained you. This question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.